Welcome everyone to the fence line monitoring session. It is 10 o'clock, so I'm going to go ahead and get started. Our first presenter this morning is Scott Manchester. Mr. Manchester is the Director in Ambient Services at Alliance Technical Group. He has 35 years of experience in air quality monitoring programs. He includes developing and overseeing perimeter air monitoring programs. He has nearly 30 years experience in project management, including over 20 years in staff and resource management. His focus experience includes a focus in ambient air monitoring of air toxics, meteorological monitoring, acoustical consulting, and odor assessment. Scott's experience includes developing community air monitoring and quality assurance project plans, and monitoring for a variety of air toxics, including a wide range of speciated VOCs, sulfides, amines, aldehydes, metals, PAHs, PCBs, and odors, including use of real-time analyzers for fence-line monitoring applications. Scott holds a Bachelor's of Science degree in meteorology from Cornell University in New York.
Thank you very much. I appreciate the opportunity to be here today to spend the next 30 minutes talking a little bit about ambient monitoring, kind of a general broad brush. I want to talk really about start with the historical air quality trends that we've seen that really drives the monitoring that's being done today. Aspects of those monitoring, it's a large field, but we're going to go through some of that. And then finally, to talk and mention some pathways or tools for effective public communication of results. Want to get started though, just by talking about what ambient air is and what it isn't. EPA actually has a definition for it, and it's that atmosphere that's outside of buildings, that in areas where the public has access to. So it's not talking about indoor monitoring. It's really not talking about anything inside a facility's fence line. It's everything outside, from the fence line out into the community. And what it also isn't, ambient air is not necessarily pollutant free. So there's always been pollution episodes that occurred, but middle of last century, we really started to, with increase in population, increases in industry, really started to increase the severity and the number of those events. So here you can see a picture here of New York City. I'm from New York State, so I really appreciate and enjoy the New York City, but wouldn't have on this day. You wouldn't want to be there. Plus, it's not just a bad place to look at and to maybe it's odorous, but resulted in a lot of deaths. So they're figuring at each one of these events that they had, and there's 3 of them in New York City in 53, 63, and 66. They're figuring each one of those probably had 200 people just as a result of that die during those episodes. So what's been done? Clean Air Act of 1970. So what's the EPA came up with Title 40 of the CFR for protecting the environment. That has 3 areas that really first in Part 50 talks about and establishes a national ambient air quality standards that drive much of the monitoring we're doing. Specific reference methods to use. So they want to have really dependable, high quality instrumentation, and then how to implement those stations and develop those networks. Because it's really important, because this is what's driving our tracking of air quality trends. And it's been a really good story. 78% reduction in emissions since 1970. And over the past 30 years, air quality has really improved by anywhere from 25 to 90%. You can see a graph on the right that just shows that steady downward trend in ambient concentrations in the community of these pollutants that are under the standards, the National Ambient Air Quality Standards. And one other thing is a public awareness. So over the past 50 years, especially over the past 30 years, we've really had an increase of public awareness. That's a really good thing. And a lot more engagement and need for engagement. So understanding and working with the community is really an important facet of air monitoring. So some of the objectives today, specifically on air monitoring, is of course documenting and tracking the air quality that they've been doing, but really it's also evaluating impacts from source impacts onto the community and seeing where they're making a significant deterioration of air quality and when they're not, and verifying that that's not happening. The other thing is protecting, obviously, our public's health and additionally welfare of the public. So I'll talk about that. In the air monitoring today, so it's following a couple of major guidelines, the National Ambient Air Quality Standards, and that's established criteria air pollutants for gaseous pollutants that they have standards for, particulate pollutants, and airborne lead as well. But it doesn't end there. So there's a lot of other compounds out there to be concerned with, and these are defined as hazardous air pollutants or air toxics, as we refer to them a lot as. 188, give or take, compounds where these are compounds where have either acute or chronic health risks, and this could be a cancer risk over a lifetime even. So there's guidelines on those, federal and sometimes state guidelines on those. But other goals of air monitoring programs these days is to really differentiate from what's being caused by on-site emissions versus there's a multitude of off-site sources there that aren't controlled but still exist, and differentiating between on-site and off-site sources, protecting public welfare. So these guidelines talk about public health. They really don't talk about public welfare so much, and public welfare is something that is going to affect quality of life. So ambient monitoring is oftentimes targeting that. It's a conduit for public awareness and communication, which is obviously what needs to be, has been ratcheted up with the community engagement these days. And then, of course, we're all concerned with sustainability of our environment and our world. And so climate protection is something that is another part, another facet. In today's air monitoring, there's really two main areas where we're doing monitoring. It's at the fence line. This is a fence line track forum here. So we're probably pretty familiar with that, but that's where we're encircling a facility or a project with monitors. So we find out what's coming from on-site to off-site so that can be regulatory driven. That can also be just to protect public harm and public health and welfare from either, again, acute or chronic effects. The other types of stations are out in the community. Those are really consist of state and local air monitoring networks, or SLAMs, which are set up and very robust monitoring. They're the ones that are going into tracking our national air quality levels. They want to maximize accuracy. So they're establishing those levels, identifying trends. The downside is they're really costly to implement. They feasibly can only put so many in. So a lot of times they need a finer look. And that's covered by supplemental informational monitoring, I want to call it here. And that's really to talk about local air quality areas. It fills gaps. They can really pepper a community with monitors and identify hotspots. Maybe they find out where they want to install another air monitoring, state and local air monitoring station. But these are lower cost systems. They're readily implementable, more cost feasible to install in higher density. So really the common types of air monitoring, there's several types that address public health. Those are the community, state and local air monitoring programs, fence line systems. I want to add meteorological stations into this, because a lot of times these go with air monitoring stations, but sometimes they're standalones and regulatory required. And the supplemental networks, which pretty much cover everything else. There's also public welfare, which is under the ambient umbrella. Maybe a couple things that people don't normally think of when they think of ambient air monitoring, but that's addressing doing noise assessments and odor investigations. So I want to talk a little bit about those, because those really affect people's quality of life. Nobody wants to be in an area that is constant odors or is too noisy. I was at JFK yesterday and I'm thinking, gosh, it's noisy here. So those are the kind of things that we want to look at. But to start off with public health, these things that can harm people's health is community, state and local air monitoring stations following the 40 CFR 50, 53, and 58. They're typically real-time analyzers. Here's a station that's set up. It's an ecto shelter, really designed pretty much for this type of purpose, frequently used by air monitoring stations. But these are temperature-controlled shelters so that the instruments can be really, you can maximize the accuracy of the instrumentation. They include on the top there are particulate samplers. They can have 24-hour integrated or real-time as well. And sometimes they have a 10-meter tower, a meteorological tower as well. That's a pretty standard height, just to supplement that data, but not always. This one doesn't in this case. What makes them really robust and high accuracy and dependable is they are backed by quality assurance project plans. That talks about their monitoring objectives, how everything's cited, the type of instrumentation. It's very thorough look of QA, QC, even has QA audits, third-party audits that are mandated so that they can really be assured that the data is going to be something they can hang their hat on for developing trends. So there's all the data quality objectives are specified, and the data goes to the EPA Air Quality System database. So it's all input, so we know where we have been, where we are in air quality, and where we're going. Fence line systems are a little bit different. Those are, as the name implied, at the perimeter monitoring networks, as sometimes they're referred to. That's really to identify when from sources that are on site, what they are at the edge of the property where it becomes ambient areas and out into the community. So they're dependent on what the facility is producing. Facility process compounds, they target those. Sometimes it's operational processes. Sometimes it's demolitions require these. Often if there's pollutants involved in that, or site remediations, almost always, where they're remediating soils and cleaning up those. They have volatile emissions. Superfund sites have them, and so again, program specific, depends on what their contaminants of concern are. Often real-time monitoring, continuous stations in a network around. Those can be individual stations, or they can be path length stations. The top left shows a setup, or the top photograph shows where there are individual stations at the corners of an area they want to do perimeter on, and then path length measuring across each side as well. There can also be they can also have periodic sampling too. So it's something you don't need to run continuously, but do need real-time data on. And we've done that for H2S and mercury, where we're taking periodic measurements as well along the fence line. There's also periodic sampling that goes along, and that really covers a gambit of different compounds that can be done. Samples can be taken on a routine basis and evaluated, a whole target list of compounds, speciated VOCs among others. One thing that sometimes in these events that also occurs is there's individual sampling events in the community too. It's not at the fence line, but as part of a fence line program, sometimes an agency will require that something's taken out in the community, and the purpose of that is really to show demonstrate to the public, yes, it's not getting by us. It's really not out there. So just to give some confidence in what the community levels are of whatever that target compound is. But there's some challenges, notwithstanding sometimes the community not necessarily on board, vandalism, or just people getting into mischief. So vandalism issues are a problem there, but the bigger problem is potential for unknown offsite sources. So you don't know if somebody's parked a car next to there, run their vehicle exhaust for 2 hours right next to the station. So when you get a hit, is it from on site? Is it from off site? Really don't know. If it's really low and good, then great, it's a good story. But there's a lot of indefinites in that type of monitoring. And just to add in meteorological stations. It's not a pollutant, but it certainly is important and required in some regulatory modeling applications, PSD permits. Typically on-site 24/7, or they're located in very open areas so they can get good flow. Typically 10 meters in height, but they can be portable. And on some of the remediation fence line monitoring systems, these are portable, that just to get into the right area. They may not be a long program, so they're not going to install a 10-meter tower. They really would need to know what the site winds are. So winds, temperature, humidity, barometric pressure are usually monitored. Sometimes precipitation too, if that's important to the project. Site, there's usually a detailed monitoring plan, not necessarily to the level of a QAPP, but on occasion, for some modeling applications, a QAPP is needed when it's a required network. And that's going to talk about the siting and what QA/QC, a little more general, and reporting, and how's that's going to work out. And again, with data uses, dispersion modeling inputs, that's the meteorological data needed for that. All fence line programs almost categorically have meteorological stations. That's to interpret on-site versus off-site, upwind versus downwind, and emergency response as well. So critical to, even it's for the facility, they may have a release. They need to know where the safe zone is, where the plume is going on a very real-time basis. So they need something they can depend on, so they get their people to safety. Same thing for tragic events that occur out in the public too. They'll set up a meteorological station as part of that, or use a local one. And finally, to fill in all the gaps is our supplemental other informational ambient monitoring networks. And these can be short-term, they can be long-term. They talk about criteria pollutants or air toxic, depending on what's important for that area. And they can be backed by public, or excuse me, privately funded, just for information. Maybe it's a background. They want to establish a background for the area that they're building on. But emergency response, again, setting up their, you can see a one on the right here. It's much smaller footprint. It's not a big station. That the business end of that is that little NEMA enclosure, that white NEMA enclosure at the top there. You can kind of get a picture of how small that is. So those can be easily deployed on demand. And one thing that's really important in the past, recent years is that the agencies are starting to come out with grants for community programs that utilize these lower cost solutions to air monitoring. And these are targeting, for example, they're recently funding high density community networks, where they're targeting industrial areas and communities around those industrial areas where maybe there was it's just an area that they really need some more information on. So they can pepper those areas with these stations and really find out more information. Again, real-time monitoring, low-cost sensors, and they're wireless to a cloud and really easily deployable and movable. But there's some performance and QC considerations for these type stations that aren't necessarily there for the big air monitoring stations, and that's, they really need to define on these what the sensitivity of the sensor they're using, and there can be multiple different choices to sensors for a certain compound. Drift, cross sensitivity, even effects of changing temperatures and humidities can affect these, and they need to really be able to compare those. And so they do that by comparing them to reference methods or near reference methods that are long established monitors, and see how they're handling all these conditions and the accuracy that they can expect from these systems. Just to highlight, just recently, actually it came out in 2022, and the grants were awarded. EPA awarded grants for what they call an enhanced community ambient air quality network. They issued those in November of 22 from the Inflation Reduction Act and American Rescue Plan. $53 million were allocated, and awarded to 132 different projects, all ambient air related in 37 different states. They're getting up to $500,000, half a billion dollars for over that 3 years to install air monitoring networks. A lot of these are targeting the communities where they either had currently have health disparities, and they want to find out maybe why that is. That could be air pollution related, maybe it's COVID related disparities, but they want to really understand the air quality in those communities. Recipients include state agencies, local agencies, tribal agencies, and as well as various community groups and universities that receive grants to start this up. And again, these are real-time, low-cost community networks, typically looking a lot at PM 2.5, some criteria pollutants, and a few of them looking at VOCs, and specifically or in total VOCs. There are also some money allocated to mobile stations and having mobile ambient stations and labs that local agencies can set up and really take where they need it, so they can maybe check out several different communities very easily. And that's looking to implement this year, middle of this year, later in the second quarter, in the third quarter. They're just waiting for the money to actually get issued by the government, federal government. But once they get going, they have a lot of plans to have some of these enhanced networks set up. So looking forward to that. And then the other area that's, again, not health, but public welfare, trying to protect the quality of life, is noise and odor monitoring. And noise assessments, and these both fall under the umbrella of ambient air monitoring. And those noise assessments, where they're doing sound surveys in the community, they can be at a fence line depending on the requirements for the community, but this is a lot of local ordinances, sometimes state guidelines, and to really determine compliance with that, to make sure the sound levels are reasonable for people. They're not being impacted, significantly impacted. Where they are is when they are impacted, then modeling can be done, or if there's a new source, modeling of sources can be done out into the community, so we can predict pretty accurately from a source near field what it's going to be out, say, a half a mile away or hundreds of feet away, and we can predict that. And then if they're going to be above or determined to be above the compliance levels of the community, then they can apply some of the typical mitigations, is just maybe wrapping it in some quieting, lagging, or putting partial or full enclosures around it, or creating outdoor barriers. That's pretty effective in reducing areas in certain instances. So that's some of the things that can be done to control noise. Very similar for odor evaluations. Those are really a measure of three things: the odor strength, the frequency of, when I say frequency, I mean frequency of occurrence. Is this something that's continuous odor, or is it an intermittent odor? And then the character of the odors. Certainly, people smelling roses it's going to be a different character than something that smells like tar, for instance, or metallic. So describing the odor is part of these ambient assessments. And we all can do this qualitatively with our noses. We can kind of differentiate between a strong odor and a light odor, and once you become familiar, you can do that pretty repeatably. But they have olfactometers that are used to identify the strength of the odor, and that's done by taking the odorized air and then mixing in clean air with no odor in, and depending on how many volumes of unodorized air you dilute it down to a point where you can no longer detect it. And that's called the dilution of threshold value. Maybe it takes 10 times to dilute something before you can no longer smell it. So that's also referred to as odor units. And that's a measure of the strength. So stronger odor takes more dilutions than it would a light odor. And those are there's some local and some state regulations that are that say maybe 7 OUs is too much, 4 OU is okay. But a lot of places don't have those, but that's something that can be directly compared. You can do that in the field with a white thing that says nasal ranger. That's an example of doing that, having an olfactometer, a field olfactometer that's portable. You can carry it around at your fence line out in the public to get a strength evaluation of the odor. Same thing that below it is one that's used in the lab. So you can take whole air samples of the air, bring it back to the lab, and an odor panel who's trained and their sensitivity is known will evaluate that. You can determine the same thing in a lab with a whole air sample. I indicated that you can compare those OUs directly, but where you don't, one of the things that in the ambient monitoring programs for odors, one of the things we do is rank the sources. So you really take the strength of the odor. It's not all about the strength necessarily at the source, but it's also about the volume of air that's coming out or volume of the emissions. So you can put into an odor emission rate, and therefore you can rank different sources at in an area of a facility where they can tell if there's an offsite odor, what's predominantly causing that odor. It may be 75% one source, and you find that out by doing a survey of all the odor sources and ranking them by odor emission rate. And again, this purpose of this is so mitigation can be applied inside. If it's an inside source, sometimes it's just modifying the process. We've had customers that have taken and switched out a chemical part of their process. They were able to do that and put something in with a lower amount of the compound of concern and control their odors that way. You can run it through a carbon unit, collecting fugitives inside. So, or off the exhaust itself. So that's another way to do it indoors. Outdoors, if it's a surface odor that's coming off, say off a remediation site even, you can put covers, you can tarp it, very simple. But that white picture, that white stuff looks like snow, is not snow. It's a foam cover that they spray over top of it. At the end of the day, they can spray this over top. It'll control the odors very effectively by blocking them. There are neutralizer sprays that literally kill the odor. Just like we have at home inside, we spray around to neutralize odors. There are also mist curtains. The lower right is a picture of a mist curtain. If you look carefully, you can see kind of a fuzziness in the center. That's a spray array that's going along the perimeter. And what that does is those spray drops go into the air, they absorb air from the odorized air, and then they drop out shortly after that. So by that way, they remove the odor out of the air, and those can be very effective as well. So finally, the third thing I want to talk about really is how does this data get communicated to the public, and what are the tools? And this is really, when we're talking to public, we're talking websites and getting data to websites. And there's a couple differences. If you have a community monitoring network where it's out in the community, those are typically set up with very open access, cloud-based. They run 24/7. Real-time data comes into these sites, and you can and anybody in the public can access them. So there's live data transparency to this and what's going on in their community. And it's important that these don't take rocket science or an IT degree to access. So ease of access, very intuitive programs, time history graphs of things so they can see current and they can see what's happened over the past week, month. They can look at that. If they're numbers people, maybe tabulated data as well. But just so they can get an idea of what's happening in their community, and a comparison of guidelines is really important in that, so that they can know, are we above an air quality standard or are we below it? Maybe it was just a moment today, but then generally for the past week, it's all been good. So that can help. Access permissions, they're obviously going to be set up with read-only access, but owners should have admin privileges so they can go in, and if there's something where something's malfunctioning, they can take it offline very easily. They can upload some supplemental data to it, and there's some QA/QC that they can do as well, and should be able to do that as well. And the other area that I want to finish up with is the fence line monitoring programs. They're critical. Having a public website on those and communicating that data to the public is really critical to a successful program. Similar to a community network, you want that data accessible, but unlike the community network, and I've seen it where they haven't done this, but I think it's really important is to validate the data before it hits the website. So because you're talking about on-site sources, you want to daily validate that data before it goes up. And because you don't want to be reporting data that raises alarms that maybe it's just something that was a malfunctioning sensor, until people think, oh, we're at risk because it's on-site reaching off-site now into our community, we're at risk. So it's important that those be called out, have that comparison. When are the guidelines for the project? And to note everything. So when the validation of the data goes and it goes up, maybe the next day, the next morning, it goes up for the previous day. It has a description. On the lower left is a dust monitoring trace. You can see the red lines are limit levels, so they can see they're well below. But there's a drop out there in the data, and it's explained. So if there's an excursion of those, or if there's a dropout in the data, it's explained. Everyone can be assured that there's not just taking out data. That was really important. There's a reason for it. So that's critical. The other critical part to communicating with the public is setting up complaint hotlines on fence line monitoring so that they can have a voice back. They can have something investigated. Maybe it's an odor that they're concerned about. And they say, oh, I smelled this odor. It's coming from you guys. And so there needs to be a hotline set up so they can communicate that and know it's going to be investigated. That really they can identify specifics about it, that maybe a time, where it was located. That helps the investigation along. And you say there's a lot of times, for instance, odors are not source related, and it's very easy to tell by the wind direction. But if it is, then there needs to be, and probably the final point of the communication is an investigative procedure set up, very clear and internal process flow chart. And these can be complicated looking, but ultimately these flow charts tell exactly what happens when an odor comes in, who it comes into, or maybe it's something that they're seeing, a visible emission. How is it going to be handled? Who is it going to go to? And how they're going to determine whether, if it's on site, where the source was, and how are they going to correct it. So all the people involved need to be interconnected in this, and so that they can be assured, everyone can be assured that this is going to be handled appropriately every time. And then an important part of this is having it, there's usually agencies involved. So having the agency be a part of that flow and involved in the follow-up, because agencies really are our friends. When we've come up with a solution and found out a source, they need to understand that it's been taken care of. And then in the communication back to the public, everybody's on board with what happened. So just to sum up, benefits of ambient air monitoring programs and communicating this to the public, it really is there. Ambient monitoring programs show our air quality trends. It shows where we've been, where we are, and where we're going. But then it also assures public health in a lot of cases. So people rely on that to make sure that they're healthy, even their welfare, that their concerns about their public welfare are being addressed as well. Communication, it provides, air monitoring provides transparency to the public. It minimizes concerns. It reduces apprehension. We have enough things to be apprehensive about these days. Air quality, hopefully this works to make sure that isn't one of those, just adding to that. And overall increases public awareness. It builds trust between facility and their neighbors, and we want to do that, and then so we can promote ultimately cooperation with the community. Thanks very much. I appreciate it. If there are any questions, feel free.
I have a question, but I have a comment.
Mm-hmm.
I live in West Texas. Windy. have an ecobee system in our house. Monitors everything. Every time my wife cooks, ecobee monitor notifies her of air quality use in the house. Please.
Wow, that's a great system. And a lot of those with the low cost sensors are going right into people's homes. So in the future, we're going to not only know how we are outside, you think indoors, oh, it's all good. No, indoor levels and indoor monitoring is not my wheelhouse, but boy, we found that inside, oftentimes that's where the worst air quality occurs, and that's where you spend all your time. So those systems are really important. Then these same low cost sensor monitoring networks that we're peppering communities with, find out outdoor air, those are being used, like for instance, indoor schools. We work with a group who does that. They've set up a huge in the Boston public school system. All the classrooms, they have indoor monitors, and they're seeing when things like they had a situation where carbon monoxide was raised. They had to look into that, and it was something where something was being entrained into the school and things like that. So those are really important, and people don't necessarily think about how much time they spend indoors in there or know what's going on. They will going forward. Mhm.
Here's one other thing. I said I live in West Texas. It's an area that you drive through that's always distinct sulfur.
Mhm.
It's from the oil and gas. But you don't understand. One, you gotta be coming from the same company, it's the same area. How do they get away with people who live out there? If you say anything about it, it's like, well, that's the smell of money. It's not. This is your health. And if you literally, you drive through there, you just have to drive through there. You have an empty stomach, it will stomach. A lot of times, this will get ahead.
Mhm.
This is not a minor odor.
Well, yeah, and that's a really good point, because I think, and I talked about health and welfare. Odors is one of them, just to take an example. People can have physical reactions. It can affect their health and odor. Maybe that level of that compound is in the safe zone. But there's an asterisk there. It's safe, but people can have, their bodies can have physical reactions. It's just like people getting nervous for something. They start to sweat. That's a physical reaction to a situation. For odors especially, people can have a reaction on levels that are well below air quality levels, but because there's an odor, it is reducing their how they feel, how healthy they feel, and they can have physical symptoms from that. That is very much a quality of life, and that affects them as well. So that's why levels are blurred a little bit, but we need to understand what those levels are that are causing that, and so and what's causing it. What are the specific sources, and you maybe identify a certain oil and gas is doing that. Um, there's also how often people are used to that. So, and noise is a big thing for this too. It's very similar to odors, where the previous exposure to the noise, if you come up with a new noise nobody's ever heard before, people are more sensitive to it. It has an impact. If it's a noise that's been around for their whole life, that's just part of the environment, and they accept that. Or it can work the other way too. If it's a noise and they tolerate it to a certain point, once they start complaining, then that generates a response in and itself. And boy, you can reduce that noise, but because they're already complaining to it, it's much harder to address. So a lot of times it's important to address these by studying them ahead of time before people are really making complaints about it.
Many of the people are.
It happens a lot. It happens a lot, but if it's a health related thing, that is there, and that we grow. EPA is learning. We're learning as a country what those levels are, how to control them, and like I say, it keeps getting better. And we're watching the trend. Things are much lower now, but that doesn't mean we're done. There's a lot more air monitoring to do, and oil and gas is one area where they're every month, and every year they're coming out with new guidelines on how to control that and how to get a handle on it. And some of it is for climate protection, obviously, as well.
They're out of town, Goldsmith, page 2 as well. Got to the point now, Gold.
Yeah.
We get a letter every morning that. Actually, them, you were.
Wow. Okay. Yeah, leak detection is a huge thing, obviously. Yeah, any other questions?
Thank you.
Thank you
all
very much.
So much. If you'd be so kind before you leave, there's a sign-up sheet here in the front of the room and also one by the door, if you wouldn't mind signing in. And there'll be another session starting at 1 o'clock in this room, an additional fence line monitoring session. Thank you.
Is this still running?
I'll take care of this.
Rhonda? Scott Manchester. Oh, you're Rhonda. I couldn't see. A lot of Rhondas. Great to meet you.
I know.
Yeah, we were really, you know, it's really a great opportunity to,
All about what we're doing.
boy, it is, and it's getting more and more, but it's a good story. We're really reining things in and learning, and with low cost sensors now, we get to pepper areas and find out in communities what's going on. But you know, communities are either they can be one way, they can be totally oblivious to what's going on, and it's their impacts, or they can be complaining about something that isn't even fair to the facility next door because it's coming from somebody else.
Right? Or, you know, randomly.
Or randomly in Philly. I mean, that's what I'm working on.
You know what I mean? Yeah, exactly.
Nice. Well, is there anything else you can obviously
So,
just help and brainstorm with you?
On the fire
Look,
things,
I'm-
I don't know what else.
I'm taking pictures.
Yeah.
Presentation.
How much?
Well,
does
it'll
that
be
program
online. I
last
think
year?
it's still recording. Let me stop if I can
Because
do this.
Yeah, but I just wanted to come up and say, hey, so.
Oh, I'm so glad to meet you. I appreciate it.
Operational.
You can hit stop, but it's still running. Okay, sure.
Really?
Yeah.
Yeah. Between you and Eric, usually. Very. I'll see you later. Okay.
Oh, good. Comments, all great input.
We're not responsive to
much. 35 years.
Yeah.
That's great.
Like, yeah.